Let's start by dragging on an output node and type TZ into the channel. Instead of typing TZ, we could actually get it from the menu here by selecting Agent and TZ. TZ will move the agent forwards, so if we set a value of 1 and then hit the spacebar to start our simulation, we'll see the agent move forwards, although rather slowly. So let's set the range of this output node to 0 to 10, and then we can set higher values. Alt R to reset. Now we can bring on a couple of defuzz nodes. Set this one to fast and connect it to our output node, and then drag on another one, set it to slow. So these set the possible values that we can have for our output node. And slow will give a value of say around that, and fast will set to 10. Now we don't actually have any fuzzy logic here to determine when it should go fast or slow, so we'll just drag on a noise node which will give us random values. So now we can randomly activate fast, and by setting the rate it will change over time. But since we don't have anything telling our agent when to move slowly, that means we've got somewhat of an undefined output value here. So we just need to set this to else. Now our agent will speed up and slow down randomly according to the value of noise. Let's copy that and paste it and change TZ to RY, because now we want to get random turning. Set the range to -100 to 100, and now we're going to change the fast defuzz node to left and the slow defuzz node to right. Now an RY of a positive value is left, and an RY of a negative value is right. And if we run the simulation now, we'll see that we have an agent that speeds up and slows down randomly and turns randomly. Great. So let's copy that, drag that up to here and bring on an input node. And this time we want TZ, and we're going to get a fuzz node and call it fast. So this will be true when the agent is moving fast, and it's up to us what that actually means. So we're going to set a range of 0 to 10 for our input node, and now we'll see this blue line in the fuzz node indicates the input value, in this case TZ, and now we can turn that into a fuzz value or fuzzy value by setting up this graph. So we selected the S type of graph, and now the output will be true, indicating that it's fast when this blue line reaches the higher parts of the graph. Now we get another input node, and we call this one RY. And we get a couple more fuzz nodes, and we're going to call them left and right. We set the range -100 to 100. It doesn't actually have to match the range of the output node that's controlling RY. And now we can set our values for left and right, so we can determine what we mean by left and right. For left, as you may remember, the values are positive. And we can up arrow to the other fuzz node. Up and down will move us through connected fuzz nodes, and set the value for right. Now as our agent runs, we get a value for left and a value for right. Let's combine our fuzz values into rules. We can make a rule that's true when fast and left are true. So fast and left. We can call it what we like, but it's quite helpful to name it after the inputs. Now we'll get another AND node, and this one will be fast and right. So if the agent is moving fast and right, then this will be true. And another output node, and this time we're going to use it for getting the agent to lean when it's moving left or right. So we'll set the channel to segment box, there is only one segment, RZ, so rotate about Z. And then we can bring on some defuzz nodes to say what kind of values we would like to set for box RZ. Let's call those left for leaning left, upright for staying upright, and right for leaning right, and connect those to our output node. We can rename this to just be lean, which makes more sense. It doesn't affect the function because what it does is set by the channel. The name is just for us to understand what we're looking at here. So it makes it easier to understand that this is lean left, upright, and lean right. So now we can connect our AND nodes to complete the rules. In this case, what we want is if fast and left, lean left, if fast and right, lean right. So we just make those connections, and we need to also make sure that we have values here. We'll set the range to -45 to 45. We want left, in this case left is a negative value for RZ, and right is a positive value. And let's not forget to set this to else, because we don't have anything driving upright. We have things saying when to turn left and when to turn right, but if we leave this undefined, then we won't get good results. So we need to set that one to else. Now let's see what we get. Okay, now our agent is leaning to the left and right, when it's going fast and left or fast and right. And we can adjust the response of that by adjusting the fuzz curves or by adjusting the defuzz values that we have here. And these may be a little extreme, so let's bring those in a little bit and see what we get. That's pretty good. So now we've got a very simple fuzzy logic brain that gets our agent to lean when it's turning.